Hello everyone, today we'll learn about logistic regression modeling. So we are diving into two powerful types of regression used in machine learning and statistics. So logistic regression and Poisson regression. So these models are super useful for solving real world problems from predicting probabilities to modeling count data. So whether you are new to machine learning or looking to refine your skills, stay tuned. So first we have logistic regression. So what is logistic regression? First up, let's talk about logistic regression. Now you might be thinking, isn't regression all about predicting numbers? Well, yes, but logistic regression is special. It's used for binary classification. It means it's perfect when you are trying to predict a yes no outcome, like whether a customer will churn or if an email is spam. So, but how does it work? The key lies in the logistic functions or segment functions. These functions take any real valued numbers and squashes it into a variable between a 0 and 1, making it deal for probabilities. So, let's quickly see this in action. So, so here's these steps to perform logistic regression in Python. So first we will import libraries and load data. So we'll start by importing necessary libraries and loading your data. So use a datasets with a binary target variable. Then we will pre-process data. We will handling missing values, encode categorical variables, and split the data into training and testing sets. Then we will train the logistic regression models. So use the logistic regression class from sklearn to fit the model on the training data. After that, we will evaluate the model, assess the model's performance using metrics like accuracy, precision, recall, and AUC ROC. So let's look at the code. So first we will import the necessary libraries, that is we will import numpy as np, pandas as pt, as import train test split, then we'll import logistic regression, and then we'll import accuracy score, confusion matrix, classification report, ROC AUC score. Then we will explicitly import ROC curve, then we will load the data set, and after that we will convert to data frame for better understanding. So we need a binary classification problem, so let's filter two classes. So here we are filtering the two classes. So features and targets um, can be x and y, and then we will split data into training and testing, and then we will train logistic regression model. Then we'll make predictions, and then we will evaluate the models, and then we'll plot our ROC curves. So let's run the code. So we got our output, that is accuracy, that is 1. We have our confusion matrix, we have classification report, and we have the ROC AUC score curve. So now let's move to our next topic. So that is Poisson regression using Python. So Poisson regression, you might be wondering what's the difference? Why do we need another regression model? So well, Poisson regression is used when our target variables represents count data. For example, how many times an event happen in a fixed period, like the number of car accidents at an intersection or the number of customer calls per hour. So the beauty of Poisson regression is that it's specially designed for modeling these types of counts. And just like logistic regression, it uses a linear relationship, but instead of predicting a probability, we predict rates of occurrences. So here are examples that include predicting. So the number of website visits per hour, the number of road accidents in a city per day, the number of calls received at a call center per minute. So here are the steps to perform Poisson regression. So step 1, we will first import libraries and load the data with count based outcomes and ensure that no negative or fractional values are present in the target variable. Then we will pre-process data, so handle missing values and add an intercept term if required. Then we will train the Poisson regression model. So use the stat model library GLM class with the Poisson family to fit the model. Then we will evaluate the model, examine model outputs including coefficient, deviance, and predicted values. So now let's look at the code. So here, so first we will import the necessary libraries if not already installed. So first we will pip install stat models, then we will import necessary Then we will import numpy as np, then we will import pandas as pt, then we will import in test split, and then we will import matplotlib. So then we will generate a synthetic Poisson distribution data set, then we will create a data frame, then we will split the data into training and testing sets, then we will add constant to the model, then we will train the Poisson regression model, then we'll make predictions and evaluate the model. We'll compare the predicted versus the actual counts. So let's run the code. So we got our output. So here is the generalized linear model regression result. So here is the Poisson regression true versus predicted counts. So in this case, Poisson regression is great for analyzing and predicting how often certain events will occur, which is incredibly useful in areas like healthcare, insurance, and even marketing. So Poisson regression is widely used in fields like healthcare. It's a fantastic tool to modeling count data and understanding events term frequencies. Mastering it opens doors to solving many real world problems. To wrap it up, let's quickly compare the two models. So, both logistic and Poisson regression use to similar approach model data, but they differ in the type of data they handle. So, logistic regression is used for binary outcomes like yes or no, or 1 0 classification. Poisson regression is used for count data like predicting how many times an event will occur in a given data. So alright, that's a wrap on today's video. So we covered both logistic regression and Poisson regression and how to implement them in Python. I hope you understood the topic. Thank you.